Welcome to Chapter 3. The topic of this chapter is descriptive analytics. By the end of this chapter, you will be able to explain what EDA is and why it is important. Explain various measures of central tendency and variability, and explain the structure of cross-tabulation table. As we saw in the previous chapter, business analytics, or analytics in general, can be classified into 4 types: descriptive, diagnostic, predictive, and prescriptive. Descriptive analytics is the most basic analytics that is used to reveal the past and the current state. It answers the question, what happened? In descriptive analytics, we can use descriptive statistics and data visualization technique to summarize the data. And the summarized data will be organized to a report or a presentation that succinctly explain the past and the current situation. A typical application of descriptive analytics is a monthly report that summarizes the business operation and performance in the past month. In descriptive analytics, we can also explore the data to find patterns in data. For instance, we can identify outliers, distinctive relationship between variables, time series trend, and so on. We can do this in exploratory way. This kind of analysis is called exploratory data analysis. We implement descriptive analytics for data exploration as a preparatory step for more advanced analytics like predictive analytics. The remaining part of this chapter mainly focuses on exploratory data analysis. But the theories and techniques that will be explained in this chapter can be used in descriptive analytics in general. Exploratory data analysis, usually called EDA, is a part of descriptive analytics, which is the lowest level of business analytics maturity. However, EDA is a very important step in data analytics project. EDA is essential because it enables the following more complicated analytics to be effective and meaningful. EDA can be an iterative process, so it does not necessarily proceed sequentially. It includes trial and error and going back and forth. Actually, in many data analytics projects, EDA takes the most amount of time. Now, let's begin by understanding what EDA is. Exploratory data analysis is an analysis that identifies general patterns in data for deepening our understanding. EDA includes summarizing variables, identifying outliers, discovering longitudinal trends, and investigate the relationship between variables, and so on. We can carry out various analyses in EDA to deepen our data understanding. Without EDA, we can draw misleading conclusions in the following analysis. For EDA, we can use descriptive analytics and data visualization, which will be covered in detail. Usually, EDA is positioned as a part of data preparation and data exploration process. EDA is an iterative process. For instance, when we completed data preparation, we go on to the next step, data exploration. However, during the data exploration, we often recognize the necessity of additional data cleaning or transforming. In such a case, we go back to the data preparation phase. Besides, we often recognize the additional data transforming and editing during the data analysis and modeling phase. So, in real cases, the data science workflow is not sequential. And thus, the boundary between EDA and other processes are fuzzy. But for simplicity, here, let's partition EDA in the data preparation and data exploration, and focus on descriptive statistics and data visualization as an essential methods of EDA. In statistics, a population means an entire pool of an object of interest. and a sample refers to a subset of the object collected from the population. Census survey is a survey in which we collect data from the whole population. Sampling survey is a survey in which we take one or more samples from the population and collect the data from the samples. Census survey is difficult to carry out, so many of surveys are sampling surveys. Suppose we want to collect the data of our employees' work motivation. In this case, it may not be difficult for us to obtain data from all of our employees, that is, a population. However, if we want to collect the data of work motivation of company employees in the world, it is not realistic for us to collect the data from the whole population. In such a case, one option is to collect the data from a certain number of employees, for example, hundreds of or thousands of employees from some companies. That is, we collect the data from a sample instead of from the whole population. There are two confusing terms, sample size and the number of samples. Some people wrongly use them interchangeably, but they are different. Sample size means the number of observations contained in a subset. The number of samples is the number of subsets extracted from the population. Suppose we collected two sets of samples from the population, like shown in this figure. Sample A contains 5 observations. So, the sample size of sample A is 5. Similarly, the sample size of sample B is 7. Here, we extracted two sets of samples from the population. So, the number of samples is 2. As a field of science, statistics is a discipline that concerns collected data and mathematical analysis of the collected data for describing data and making inference from data. As suggested in the definition, statistics can be classified into two broad categories, descriptive statistics and inference statistics. This categorization is based on their purposes. Descriptive statistics is describing, summarizing, and displaying data. It is used to capture the whole picture or parts of the data. It is also used to compare the characteristics between subgroups included in the data. Inferential statistics is used to make inferences from the data. In most cases, we cannot obtain data from all the targets. Inferential statistics is used to make inference in such a case. It consists of methods to make inference about the whole population by analyzing a sample. It enables us to draw some conclusion from sample data without seeing the entire population. Based on the number of variables included, EDA can be classified into univariate analysis, bivariate analysis, and multivariate analysis. Each type of analysis includes non-graphical and graphical analysis. Non-graphical analysis mainly uses descriptive statistics. Graphical analysis uses data visualization methods. In univariate analysis, we analyze just one variable. As a univariate analysis, we describe the metadata, summarize data, and see the data distribution. In bivariate analysis, we analyze the relationship between two variables. When both of the two variables are numerical, we can do correlation and simple regression analysis. When either or both of the variables are categorical, we can see the difference between categories. This analysis is called segmented univariate analysis. Multivariate analysis includes more than two variables. Broadly, multivariate analysis includes bivariate analysis, but let me define multivariate analysis as the analysis of more than two variables. It is because different methods should be applied when the analysis includes more than two variables. When the analysis includes 3 variables and at least one of them is categorical, we can implement segmented by variate analysis. When all the variables are continuous or analysis include more than 3 variables, we can use advanced multivariate analysis technique like multiple regression analysis or MANOVA, and so on.